Essential points to remember in EDUC 502, Educational Statistics. Educational statistics is a vital discipline that applies statistical methods to collect, analyze, and interpret data related to education. It serves as a cornerstone for evidence-based decision-making, empowering educators, administrators, and policymakers to improve various aspects of educational systems. By leveraging these methods, stakeholders can gain insights into student performance, institutional efficiency, and disparities in educational access, enabling targeted and effective interventions. In the realm of educational statistics, understanding the types of data is crucial. Data can be broadly categorized into qualitative and quantitative forms. Qualitative data describes characteristics or behaviors often collected through interviews, open-ended surveys, or observational studies. For instance, examining students' attitudes toward online learning requires qualitative approaches. On the other hand, quantitative data, which includes numerical values, is used to measure or count variables such as test scores, attendance rates, or the number of students enrolled in specific programs. Quantitative data can be discrete, involving countable values like class sizes, or continuous, involving measurable values like average grades. Categorical data, representing groups or categories like gender or grade level, is another key type of data often used in educational research. Effective data collection methods form the foundation of sound statistical analysis. Surveys and questionnaires are widely used for gathering large-scale data, such as national literacy surveys. Standardized tests offer measurable insights into student learning outcomes, while observational studies provide valuable information about classroom interactions and teaching methodologies. Additionally, institutional records, including enrollment numbers and graduation rates, serve as reliable sources of historical and administrative data. Analyzing collected data often begins with measures of central tendency, mean, median, and mode, which summarize datasets by identifying their central point. The mean, or average, is calculated by dividing the sum of all data values by their total count, providing an overall measure. The median represents the middle value in an ordered dataset, offering insight into its distribution, while the mode identifies the most frequently occurring value. These measures are complemented by measures of dispersion, such as range, variance, and standard deviation, which describe the spread or variability of the data. For example, while the mean score of a class may be 85, the standard deviation reveals how much individual scores deviate from this average. Understanding relationships between variables is another core component of educational statistics. Correlation measures the strength and direction of relationships between two variables, with values ranging from -1, strong negative correlation, to +1, strong positive correlation. For instance, there may be a positive correlation between the hours students study and their test scores. Regression analysis goes further, predicting the value of one variable based on another, such as using attendance rates to estimate academic performance. These methods enable educators to uncover patterns and design interventions tailored to specific needs. Probability and significance testing are integral to drawing conclusions from data. Probability assesses the likelihood of events occurring, while significance testing determines whether observed results are due to chance or reflect actual effects. Hypothesis testing involves evaluating the null hypothesis, which assumes no effect or relationship, against the alternative hypothesis, which suggests otherwise. For instance, a school might test whether a new teaching method significantly improves student outcomes compared to traditional methods. Inferential statistics enable researchers to generalize findings from a sample to the broader population. Sampling techniques like random and stratified sampling ensure representation and accuracy. Common inferential methods include t-tests for comparing means between groups, ANOVA for analyzing differences among multiple groups, and chi-square tests for examining relationships between categorical variables. These tools are essential for conducting rigorous educational research. Visualizing data effectively is crucial for communicating findings. Tools such as bar charts, pie charts, histograms, and scatter plots present data in intuitive formats, helping stakeholders grasp complex concepts at a glance. For example, a bar chart might compare enrollment rates across schools, while a scatter plot could illustrate the relationship between teacher qualifications and student performance. Educational statistics has practical applications across various domains. It aids in analyzing student performance, identifying trends in test scores, and targeting interventions for underperforming groups. Policymakers rely on statistical data for resource allocation, such as distributing budgets or deploying teachers where they are most needed. Program evaluation is another critical area, with statistics assessing the effectiveness of curriculum changes or new teaching methods, ensuring continuous improvement. Ethical considerations are paramount in educational statistics. Researchers must protect participants' privacy and confidentiality, avoid biases in data collection and analysis, and maintain transparency in reporting findings. Ethical practices build trust and credibility, ensuring that statistical methods serve their intended purpose of improving education. The role of technology in educational statistics cannot be overstated. Advanced software like SPSS, Excel, and R facilitates complex analyses, while learning management systems, LMS, integrate statistical tools for real-time monitoring. These technologies enhance the efficiency and accuracy of statistical processes, enabling educators to focus on insights rather than computation. Advanced statistical techniques offer deeper insights into educational phenomena. Methods such as factor analysis identify underlying relationships between variables, while cluster analysis groups data points with similar characteristics. Time series analysis tracks changes over time, providing valuable information for long-term planning, such as monitoring annual enrollment trends. Despite its benefits, the field of educational statistics faces challenges. Data quality issues, such as incomplete or inaccurate records, can compromise validity. Limited resources, including a lack of tools or expertise, hinder schools from adopting advanced analysis methods. Resistance to change also poses a barrier, as educators may be hesitant to embrace data-driven approaches. Addressing these challenges requires investment in training, infrastructure, and a culture of openness to innovation. In conclusion, educational statistics is a powerful tool for improving education. By mastering its principles and methodologies, educators and policymakers can make informed decisions, allocate resources effectively, and continuously enhance the quality of education. As the field evolves, embracing ethical practices and technological advancements will be key to unlocking its full potential. This knowledge not only supports immediate educational goals, but also lays the groundwork for future innovations in the pursuit of equitable and effective education systems.